In last week's lab, we had a look at the standard template libraries list structures. This week, we're going to be looking at a stack structure. A stack is an abstract data type in which elements will be added and removed from only one end. And it is last in, first out. So whatever the thing you push onto the stack, the most recent thing, you have to access that most recent thing to get at anything underneath it. If you consider a stack like a pile of plates is the most common example, you're always reaching for the top plate. If you're putting more plates in, you're putting them on top. Usually you're not pulling from the middle, because if you pull from the middle, maybe it might fall over and your plates will break, and then your stack's just in a mess. So you're always putting things on the top and removing things from the top. Now, stacks are a little bit more niche than having just a list container, but some uses they have is determining well-formed parentheses. So they see a lot of use in different forms of math, such as reverse Polish notation as well. And compilers use stacks to keep track of operation calls, recursion, and just most things involved with programming use stacks. They analyze syntax for nested components, loops. Essentially, a lot of compilers just sort of save states of information and keep pushing it down, and then retrieves it one at a time, popping it back out as it sort of clears through all the different functions and commands it was given. So, typical operations of a stack, you can check if it's empty or full, if they have a limit. You push items down onto the stack, providing the item type and item. And again, when you pop something from a stack, you're removing it from the stack altogether. So popping something out both gives you a reference to that item, but also removes it from the stack. And then if you just want to see what's on top, you can also just check the top of the stack. So one application that you could use it for is determining well-formed expressions with parentheses. And this is going to be a section that outlines an algorithm for determining whether or not an expression is well-formed. And when an expression is well-formed, it means it has, for every opening parenthesis, it has a closing parenthesis and the same type of parenthesis in the right order. So if you had a square bracket, parenthesis, closing square bracket, that would be well-formed. If you had those mixed up, it would not be well-formed. So we have a couple examples of those here. Why do we care about that? Because balancing parentheses is very important for compiling, because if parentheses aren't balanced, either you get compilation errors or very unpredictable results. So the algorithm that we are going to be having a look at is given an expression with characters and parentheses, braces and brackets. We're going to determine if the expression is well-formed by following an algorithm and a stack. So first, we are just going to read the first expression character. If the character is an opening symbol, either an opening parenthesis, brace, or bracket, we will push it down onto the stack. And if we encounter more opening symbols, we're just going to keep pushing them down onto the stack as we encounter them. If the character is neither an opening symbol or a closing symbol, we kind of just ignore it, because we're not interested in what's in between the parentheses, we're just interested in if the parentheses match. But if we encounter a closing symbol, we're going to check if the stack is empty. If the stack is already empty and you have a closing symbol, then there cannot be a matching opening symbol, so you already know it's not worked. Otherwise, you're going to pop the character on the top of the stack, check and see if it matches the same closing symbol, so you don't have a parenthesis and a closing brace, because if you have that, it didn't match. And if they balance each other, you're going to keep balanced as true and keep moving on reading. If they didn't match, then you are going to produce an error saying the expression was not well formed because there was closing parentheses or braces that didn't match the opening parentheses or braces in the stack. So an example with this, you're going to push this parenthesis ignore the X, push that brace, ignore the X, push that bracket. You'll encounter the first closing bracket. So when you're popping a stack, the most recent thing that went into it will be the first thing that comes out. So since we're encountering that, we're going to pop the first item on the stack, which is an opening square bracket. That matches. We'll next read the closing curly brace. We'll pop that. The next thing that would be left on the stack would be this brace here. So we'll pop that, it matches. Ignore the X. Pop the last parenthesis, it matches the opening one. And now that the string's over, every parenthesis bracket and brace had a match, which means the expression is well formed. And there's a graphic representation of that here.